Okay, this is Mr. Peterson, and I'm returning to the 6.6 notes. This is the fourth and final page of the note set. And these last two problems in this previous section, where I was teaching you type 1 logarithm ones, um, they're paired to show you the importance of checking your work. These two problems are going to give similar answers. And yet, when we really look at it carefully, and check our work, you'll find out they give different answers. So I want to point out that we have a logarithm involved in both sides here, logarithm there, logarithm there. So these are type 1 problems. Okay, we're going to take the 2 that's in front of the logarithm here and use the power rule to bring it up to the inside. And then since you've got a log base 4 of both sides here, you can cross that off both sides. And that takes us to x squared equals 9, which if you square root both sides and take into account the positive and negative answers, gives 3 or negative 3. The negative 3, however, does not work in the original problem. So I've labeled as extraneous and crossed out the equal sign. On the other side, example 12, we start out by getting rid of the logarithm off both sides. And you can see very quickly that this turns out to be following the same path as before. There is a major difference, and that's that if you take this answer 3 and store it for x, it works over on this problem, and on this side you get equal amounts. So that's a legitimate answer. The negative 3 also works. So unlike the previous one that looked like the same problem, we have two answers this time instead of one answer and an extraneous false answer. So you can see that you would never know that unless you actually plugged in 3 and tried it, and negative 3 and tried it. So always check your answers for extraneous. Make sure you got the right answers, okay? All right, type 2. Type 2 problems have at least one term that does not have a logarithm. So I'm going to highlight that on these first two problems. This minus 2 there does not have a logarithm associated with it. Likewise over here there's a 2, and maybe I can take a sneak peek at the next two problems here. There's a minus 3 there that does not have a logarithm attached to it, and then we have another one here with a 2, and there's no logarithm on that too. So that's how you tell it's a second type of problem, and we're going to take a different tact. What we're going to do here is separate the constants onto the other side, the parts without logarithms on it, before rewriting it in exponential form, essentially going what I like to deem around the world with it. Okay, so this minus 2 here needs to go to the other side. The logarithms have to come over and join each other. So first, take the negative 2 over, and you can see I've got a positive 2 on the other side, and bring that logarithm back to join its partner. So now what we're going to do over here is use the quotient rule and rewrite this side. And now we're going to take a very different approach than we did last time. We're going to say 4 to the second power, sorry about that, let me do that again. 4 to the second power equals x squared over 3. So we're going to unravel this and write an exponential equation instead. And you can see that here. I've already started to solve it. It's 4 to the second power equals x squared over 3. You take the base, come over here to pick up your exponent, and then rewrite that expression. So it's 4 to the second power is x squared over 3. Now you can see I've already started the solving process. I'm multiplying both sides by 3 here. And then I take the square root of the 48 that you get, and the positive and negative versions of it, only one of them works. Okay, let's do that again on the next problem. We're ready to unravel this. I'm going to go 3 to the second power equals 4x minus 5. 3 to the second power equals 4x minus 5. We'll simplify the 3 squared and add 5 to both sides. And then the 14 we get on the right divides by 4, and you get 7 halves, which is 3 1/2. And that answer checks in the original problem. Okay, here's another example. The part that we're going to get over the other side, we're going to take this 3 over there and bring that logarithm back. So that'll take us to, sorry, wrong tool there. That'll take us to natural log of x minus natural log of 2 equals 3. Hopefully you can see that the quotient rule is going to come into play here. So that's going to be natural log of x over 2 equals 3. And I'll take the base over here, it's e. E to the third power is x over 2. And you multiply both sides by 2. And convert to decimal using your calculator. And then you want to make sure you take that 40.171 and store it for x. Type this side, type the other side. Those amounts should equal each other. Okay, last example here on the note set. We got to get the plus 2 on the other side of the problem. And then we'll do something similar with this. In other words, we're going to take this over to the right and this over to the left. Let's see what that looks like. Okay, now with a plus sign between those logarithms, you know that the product rule says that that's going to be multiplication. And then I'm going to take the base, happens to be 10 since it's not written. 10 to the negative 2 equals 2x. That'll be the next step. And divide by 2. Or I took a half of both sides. And then if you type that in your calculator, you get 0.005. And storing that for x, you can check it by typing the left and typing the right and seeing if they're equal to each other. And that last answer is a legitimate answer as opposed to an extraneous answer. So I hope this does it for you, and you guys do okay on this section here. And I'll see you in class next time.